Okay, so this is our next section in this chapter, estimating parameters and determining sample sizes. In previous section, we estimate using population proportion or sample proportion. In this section, we use estimating using the mean estimation. So the goal is use the sample mean to estimate about the population mean. We have these three, this section is very similar to the previous section. Instead of using the proportion estimation, we use the mean estimation. So in this case, point estimate is the mean estimation. Sample mean is the best point estimation for the population means. We also have to find out the confidence interval and then sample size, the very same thing we did in previous section. So our objective here is construct a confidence interval used to estimate the population mean. For that, these are the notation we're going to use. Mu stands for population mean, x bar sample mean, s sample standard deviation, n is the number of sample values, and e is the margin error. These are the requirement to create the confidence interval for estimating a population mean with the standard deviation is not known. The sample should be a simple random, and your distribution should be either population distribution should be either normally distributed or the sample size should be greater than 30. So this is the formula we use for finding the confidence interval, x bar minus e and x bar plus e, similar to the confidence interval in sample proportion in previous section. And the one big huge difference here is we use critical value t critical value. Instead of g score, we use the t score. So what is t score? We're going to define that in next slide. So, but the finding the value of t score is very similar to finding the value of critical value g score in a previous section. Here we're going to use degree of freedom DFF, which is actually sample size minus 1. Okay. So here also we have confidence level, like we had a confidence level in previous section, and critical value, which is in this case it's a t value, t alpha over 2 is the critical value t separating an area of alpha over 2 in the right tail of the student t distribution. Keep in mind the distribution here we're using is called student t distribution using this t value, and then that t value is actually can be found by using this formula. If you notice, this formula is very similar to this one. This is for the g score, where we use the standard deviation for the population. Here we don't know the standard deviation for the population, that's why we use the standard deviation for the mean, and that distribution here is called student t distribution. Other than that, rest of the things we find very similarly as we found in previous section. So degree of freedom, that is actually n minus 1. So actually when we choose the sample of size n, the degree of freedom tells us how much freedom we have in a way that we can choose our our elements in the sample very freely. That is n minus 1. Because if there is n number of sample, and if that sample has to satisfy some other requirement, then based on that requirement you can freely choose n minus 1 elements, but the final one is not free because you have to fulfill that requirement. Okay, so now we can use the technology as we did in a previous section for finding the critical value g. Here it's a critical value t, and the t distribution is a little bit different than normal distribution. When n is the sample size, when n gets larger and larger, finally that t distribution becomes normal distribution. So some of the key points you have to understand about the t distribution. Student t distribution has the same general symmetrical bell shape as the standard normal distribution. Student t distribution has mean of t equals 0, as a normal distribution has a mean of z score 0. The standard deviation of the student t distribution varies with the sample size, so it's not like the standard normal distribution. as the sample size n gets larger, the student t distribution gets closer to the standard normal distribution. So here are the some steps you need to follow while constructing confidence interval. So first of all, we need to verify the two requirements. The first thing is a sample should be simple random, and then either population should be normally distributed or sample size should be greater than 30. That's the first requirement. Second requirement is with the unknown population standard deviation, which is usually happens in real life situations or problems, n-1 degree of freedom, and we have to use n-1 degree of freedom, and we can calculate the t value. Finally, margin of error can be calculated by using this formula. Okay, so and we can find out the this is our confidence interval, and which can also be written as like this is like previous section, but instead of sample proportion we use sample mean. Okay, and there are rounding rules when you do the problems in my lab math or my stat math, then you will be able to see the instruction for rounding. But if you don't have the instruction for rounding, you can always use the general rounding rule. So if you want to find out using the interval confidence confidence interval, if you want to find out the population mean, point estimate of mean can be calculated by using this formula, which is upper confidence limit plus lower confidence limit divided by 2. And then margin of error can be found by using this formula, which is upper confidence limit minus lower confidence limit divided by 2. So while choosing the correct distribution, keep in mind if standard deviation for population is not known and normally distributed population, or the standard deviation is not known. Whenever standard deviation is not known, we use t distribution. And if standard deviation is known, then we can use normal distribution g score for choosing the correct distribution. Okay, and sometime based on our confidence level or confidence interval, we need to find out the sample size, and there is a formula for the sample size. We are going to use this notation for formulas. So these are the same notation, and this is the formula we're going to use for finding the sample size, which is, if you already know standard deviation for the population, then a sample size can be found by using this formula, which is in this case it's a g score divided by margin of error times standard deviation for the population, the square of that helps us for finding the margin of error. As you know, in the previous section, there is a round of rule you need to follow. So to use this formula, as you can see here, there is a standard deviation for the population. If standard deviation is not known, if standard deviation is unknown, then we can follow this technique, range rule of thumb. Use the range rule of thumb to estimate the standard deviation. So standard deviation is approximately equal to range divided by 4, and that's the one thing we can do. Second thing is start the sample collection process without knowing a standard deviation, and then finally use the standard deviation of that sample as a standard deviation of population. And then estimate use prior results. Sometime we can also estimate for the standard deviation using previously known results. Okay, when determining the sample size n, any errors should always be conservative, in the sense that they make sample size too large instead of too small. Okay, so these are the things you need to keep in mind while doing the your problems from this section. So let's see some of the problems from this section. Okay, this is the section. In this problem, we just have to look at the data given here and answer the question. Refer to the accompanying data here that result from a simple random sample of times in minutes between eruption of the old faithful geyser. The confidence level of 95% was used. Complete part A to B. Okay, so this is the actually confidence interval. So whenever you try to write down the lower value for the confidence interval, that is 85 point rounded to the 2 decimal place 74, and upper value is just copy that value from given information. Okay, identify the best point estimate of the mean. The point estimate of mean is this one, sample mean. That's the best point estimation. Best point estimation of the mean is sample mean. Okay, and then margin of error, it's not given here, so we can go back and check what is the formula for margin of error. The margin of error can be found by using this formula. So let's no, that's not margin of error, sorry, that's the number of sample size. Margin of error can be found by using this formula, which is upper confidence limit minus lower confidence limit. So as you can see here, the upper one is 91.76. So I am going to use a calculator here. So let me just use the calculator. Where is that? Upper okay, so in this case we have given upper 91.76 minus 85.74, that's the difference, and divided by 2, that gives us margin of error, which is 3.01. Okay, that's number one. Let's look at next question. A data set includes 104 body temperature of healthy adult humans having a mean of 98.7 degree Fahrenheit and a standard deviation of 0.66 degree Fahrenheit. Construct a 99% confidence interval estimate of the mean body temperature of all healthy humans. What does the sample suggest about the... Okay, so there are two questions we need to answer here. We need to create the confidence interval here. So as you can see, confidence interval means you need to find out these values. What is that? This is the confidence interval. It's a sample mean minus E, which is margin of error. So you need to calculate the value of E. E can be calculated by using this formula, which is what is that? T value times sample standard deviation, which is S over square root of n. Sample is standard deviation divided by square root of n. So in this problem, as you can see here, to find out sample mean is already given. Sample mean is 98.7 and standard deviation for the sample is also given. So the only thing we need to find is this margin of error, which is E. For that we need to find out the T value, and for the T value, if you use your TI-84 calculator, if you have TI-84 calculator, then that would be very good news for you, because they have like we calculated a G-score in previous section. We use second variance, and then we use number 3 as inv norm to calculate the G-score for given alpha. And if you are using TI-84 calculator, then there is a number 4 has inv T, meaning it gives you the T-score for given area under the curve. So here in this case, what is that? 99%. So alpha is 1 and alpha over 2 is half, which is 0.005. So like we calculated the G-score, there's supposed to be number 4 as an inv T score, but unfortunately TI-83 doesn't have that command here, so I'm not able to use that thing here. So I'm going to use something else. I'm going to use stat, and there is a test, and under the test, if you go down number 8, it's a T interval. By using this command, and then using the information provided here, there are different ways we can give the inputs. Data, if the data is given, then you can use the data, raw data, or you can use the stats. In this case, stats, we're going to use the stats because the mean and then standard deviation is given. So instead of stats, if you have some data like actual data, then you can use this data here. So use stat, enter, and now go down and give the mean, which is in this case it's a 98.7, 98.7, and then this is the standard deviation for the sample, which is in this case it's a 0.66, and the value of n is 104, and then the confidence level we need is 99%, and if you go down here, it's going to calculate your confidence interval. Okay, so that's the command you can use. This is our confidence interval, 98.53, 98.53, and go up here. Where is that? Okay, 98.87, 98.87. Okay, that's right. Now, what does this suggest about the use of 98.6 degree Fahrenheit as the mean body temperature? As you can see here, 99%, we have 99% confidence level that the mean would be greater than 98.53, but if we choose 98.6 as a mean, then this suggests that, what is that? This suggests that mean body temperature could be very possibly, no, this suggests that mean body temperature is higher than 98.6. This suggests that mean value temperature could be higher than, no, it's 98.6 degree Fahrenheit. It's 98.53. No, this suggests that mean body temperature is lower than 98.6. 98.6 is greater than this and lower than this, so it suggests that the mean body temperature 98.6 could be very possibly 98.6 because it is from here. Okay, let's go to next problem here. Okay, so this is a sample size problem. Now we know how to find interval and then the t-score using this TI-83 or TI-84 calculator. Now we go to next problem here. Let's see, it's a sample size. An IQ test is designed so that the mean is 100 and then standard deviation is 19 for the population of normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students such that it can be said with 90% confidence that the sample mean is within 8 IQ points of the true mean. Assume that sigma, which is standard deviation for the population, is 19 and determine the required sample size using technology. So as you can see here, there is a formula for the sample size. This is the formula. You need to find out the g-score and then sigma divided by E. So first of all, what is g-score here? Where is that? IQ test is designed so that the mean is 100 and then standard deviation is 19 and then confidence level is 90%. So 90% means the value of alpha is 10% and alpha over 2 is 5%. So if you just try to find out the g alpha over 2, which is second variance, and then number 3, 5% to the right. So to the left it would be 95%. So to find out the g-score to the left, where the area under the curve is 95% is 1.6444. This is the value of the g-score here in this formula. So we need to multiply this by standard deviation we have given here. Standard deviation for the population is 19. So I'm going to multiply this by 19 and then divide it by margin of error. As you can see here, the sample mean is within 8 IQ points of the true mean. So that's the margin of error. So that's 8 is the margin of error. So just divide it by 8. And since this formula says that just square them, whatever calculation we got here, the answer, just square that answer. So I'm going to square this, and that would be the sample size, but the rounding, the sample size rounding, round off rule is round it to the next large number. So if you round it to the next large number, it would be 16. So the sample size should be 16. Okay. Okay, would it be reasonable to sample this number of students? 16 sample size? Yes, it's a reasonable. Yes, this number of IQ test score is fairly small number. Yeah, 16 is fairly small number, so that's a reasonable. Okay, before doing this problem, okay, let's try to answer this question. The number of blank for a collection of sample data is the number of sample values that can vary after certain restriction have been imposed on all data values. The number of degree of freedom, this is the degree of freedom for a collection. So just it's a definition. I want to do one more example where you need to find out okay, let's go here. Okay, so let's look at one problem where we need to find out t-value. So this is the problem we have given. Here are the summary statistics for the weights of Pepsi in randomly selected cans. The number of the sample size is 36. Average is 0.8241 to pound, and then standard deviation for that sample is 0.00567 pound. User confidence interval level 95%. And to find the t-value, as you can see here, it's very similar to the g-score, but if you try to use like a g-score, if you go here, if you have TI-84 calculator, then use second and this distribution and go to number 4. If you have TI-84 calculator, then number 4 you will see inv t, and under that just put alpha over 2. In this case it's 95%, so alpha over 2 would be 2.5%. so to find out the t value, just use inv t 0.975, which is that function will give you the t-score for t-score such that the area under the curve to the left of that score is 97.5%. But unfortunately I don't have that key available here, so I'm going to use stat and test and number 8, which is TI interval. So in this interval, to find out the t score, we always have to use mean 0, and then standard deviation, it's actually the square root of whatever n you have given. In this case it's 36, so the square root of 36 is 6, and then value of n. By giving this value, it will give you the confidence interval, and that will help us for finding the t-value here. In this case confidence level is 95%, so 0.95, and if I just go down here and calculate it, it's going to give me the confidence interval, and then upper value of that confidence interval would be our t-value, 2.03. 2.03. So I just use TI-83 calculator without having that command here. But if you have TI-84 calculator, then you have inv t command, and you can use that command for finding the t-score. So now find the margin of error. This is the formula for margin of error. Multiply this t-score by the standard deviation for the sample and divide it by square root of n. In our case, as you can see here, this is the value 2.03. that's a t-value, times it by what is that, standard deviation for this mean for this sample, which is 0.00567, and divided by square root of n, which is 6. So if you do that, that will give you the margin of error, which is 0.00192. Rounded to the 5 decimal places, that's what it says. 0.00192 is the margin of error. Now for finding the confidence interval, just subtract this margin of error from the mean, which is I'm going to do that. If I subtract this, like what is that, from the mean is 0.82412. Look at here, 0.82412 minus, and I'm going to subtract this this answer, whatever answer I got here on the top, that is the lower bound, so that is 0.8222 and 0, 0.8222 and 0, 5 decimal place. And for finding the upper bound, just add this mean with the margin of error, and that will be as you can see here, it's a mean is 0.82412 plus the margin of error, which is 0.00192, and that gives me the upper bound, which is 0.82640. 0.82640. So check your answer. That's good. According to this result, we can say that one has 95% confidence that the interval from the lower bound to the upper bound contains the true value of the population mean weight of Pepsi in a can. This is the right option. That's the right option. The only thing you have to remember from this problem is how to find how to find the t value using TI-83. If you have TI-84, go to the second variance and go number 4. If you don't have TI-84, if you have TI-83, use the command, whatever command I showed you. Okay.